Okay, let's begin. Day 3 continued. When we are trying to prove that triangles are congruent, we have 5 different ways. Okay, so we can say that 2 triangles are congruent through side, 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 angle, side, angle, angle, side, and hypotenuse leg. This last one is the only one that is 2 things, hypotenuse leg, and this is the only exception here, and it's because we have a right angle here. Technically, it's still a 3, and I'll show you why. So first, if 3 sides of one triangle are congruent to 3 sides of the other triangle, then the triangles are congruent. So I have if AB is congruent to DE. BC is congruent to EF. They have 2 marks, 2 marks. And AC is congruent to DF. Then I can say the entire triangles are congruent. So ABC going down the leg of 1 to 2. So D to E, E to F. And a little triangle mark in front of it. I can do side, angle, side. So side, angle. So 2 sides and the angle included, or the angle in between them. So if AB is congruent to DE. BC is, let's do the angle. Angle B is congruent to angle E. BC is congruent to EF. If I have a side, an angle, and another side, then the triangles are congruent. So triangle ABC is congruent to triangle DEF. I can have angle, side, angle, so 2 angles and the side that makes up those 2 angles, or the side sandwiched between those angles. So I can say angle A is congruent to angle D. 1 mark, 1 mark. Side or segment AB is congruent to segment DE. And angle B is congruent to angle E. If this is true, then I can say the entire triangles are congruent, which means the corresponding parts would be congruent. So C could be congruent to F. So triangle ABC is congruent to triangle DEF. Next, I have angle, side, or angle, side. So 2 angles and one of the sides that is not between them. So 2 angles and a non-included side of the triangle are congruent. Then the triangles are congruent. So angle A and angle D. Angle B and angle E. Segment BC and segment EF. Then the entire triangles are congruent. DEF. Hypotenuse leg. This is the one that's for a right triangle. If the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. So we also have an angle here. So we have an angle and 2 sides. So if we see an angle and 2 sides, there is no, so these are AAS, ASA, SAS, and SSS. There is no ASS. There is no angle, side, side. So this is where we're looking for hypotenuse leg. Right angle, one of the legs, and this is the hypotenuse. It's hypotenuse because it's opposite the right angle. So we have the hypotenuse, BC, is congruent to EF. One of the legs, AB, is congruent to DE. Then I can say the entire triangle is congruent. If you cannot use one of these 5 things, you do not have enough to prove the triangles are congruent.